Let me show you how to solve conservation of energy problems with gravitational potentials and electrical potentials. Okay, remember that. We've got these equations here, right? This is the potential energy, right? So EP is potential energy, right? Okay, what they're saying is that it's the mass times the gravitational potential, right? If you recall, the gravitational potential is the opposite of G M over R. Okay, and remember, so if we have a mass, remember that it's like the sheet of rubber, right? We've got a mass here, and then there's going to be this potential curve like that, right, coming out from it. So that if we put a mass on a sheet of rubber, that mass creates this negative potential, and that's why there's a minus sign on there, right? So if we have little bullets and the bullets approach this, they're going to go faster and faster as they approach. And if we have a bullet that's leaving the surface of the moon or something like that, it's going to go slower and slower. Okay. Ultimately, its total energy is going to be 1/2 mv squared. This is the moving one, right? Whatever one is moving is, I think, the little m, right? Okay. Plus opposite of G mass over R. Okay, so ultimately the total energy, this is it, right? And these problems are just simply a matter of setting the total energy before equal to the total energy after. Don't forget the minus sign, okay? And it should all work out, right? Now on the electrical potential side, things get a little more exciting, right? Remember that electrical potential is, of course, KQ over R. Now, whether it's a negative potential, that is, it pushes the sheet of rubber down or pushes it up, it can do both, right? So the sign determines whether you have a situation where it's pushing the sheet of rubber up. If it's a positive charge, right, then we've got this positive charge and the sheet of rubber is pushed up, right? Okay. And if it's a negative one, then it pushes the sheet down, right? Okay. So this is a positive charge, right? A negative one is going to push the sheet down, right? Okay. And then this is really a bad shape in between there. It would be smooth. It wouldn't have these little hummocks there. Okay. Anyway, that's the notion. So in this one, when you look at that, these signs are important. If it's a positive and a positive, they're going to repel each other. They're going to get slower as they approach and faster as they recede from each other, right? If it's a negative and a negative, it'll still be positive, right? Negative times negative, this is a positive potential. So again, two negatives will slow down as they approach each other and speed up as they get farther away from each other. But if one's positive and one's negative, then it'll be just like gravity, right? A positive times a negative will be a negative thing, right? So in general, for this guy, you're going to go 1/2 mv squared plus k q1 q2 over r, right? And be very careful about this, right? If you set it up, don't ignore the minus signs, okay? Don't ignore the signs. And it will all work out, right? So kinetic energy plus potential energy, okay?